The Coriolis Effect by Tobin, Houchin, me. Have you ever looked at an image of a hurricane? Ever wondered why planes never fly in a perfectly straight direction to their destination? Seen a diagram of ocean currents? Or wind direction? All of these things have something in common, something that affects the world everywhere.
The Coriolis Effect. The Coriolis effect is a natural phenomenon that occurs due to the rotation of Earth on its axis. It describes the effects of the spinning of the Earth on things such as ocean currents and weather patterns, though it has effects on everything on Earth.
On most objects, the results of the Coriolis effect are too minuscule to be detected. It is not the cause of the direction of toilet flushes, as popular myth would have us believe. But on things like airplane flight paths, Coriolis must be considered, for it can have very apparent consequences.
But to be able to understand how the Coriolis effect acts on things such as water and air, we must first understand what it is.
So, most everyone knows that the Earth rotates on its axis, which sprouts from the poles. Since the Earth is a sphere, fatter along the equator, locations on 0 degrees latitude have to move faster than, say, the Arctic Circle to make a full rotation in 24 hours. Much faster. The Earth spins at approximately 1,040 miles per hour at the equator, to almost nothing, right at the poles.
That's a large distance to get your head around. Let's scale down.
Imagine you're a dancer, like my teammate here, practicing your turns in your studio. Let's use the turn to model the Earth. The dancer's leg acts like the axis of the Earth. The toe has to move much faster to keep the line and make a full rotation in the same amount of time as the standing leg. Or, dancers are polkaing, keeping their line. If they are to turn in a circle, the outside person has to move much quicker than the inside person to keep the line. The same happens with the Earth, the poles, and the equator.
Now, how does that lead to the Coriolis effect?
When objects travel, they move at the same revolving speed as the places they left. So, if they change position drastically, north or south, they will appear to curve to the right to the northern hemisphere and to the left in the southern. Imagine you had a dragon. You and him lived in Texas. You want the dragon to fly straight north. You'd expect him to land in, say, South Dakota, directly north of Texas, right? In reality, the dragon's flight path will appear to curve because it still has the east-west spinning speed of Texas. But don't think about it like the dragon was flying curved. No, he was flying straight, and South Dakota just hadn't caught up. The same principle describes plane flights. Pilots have to take the Coriolis effect into account, or they'll end up somewhere else, waiting for their destination to come to them.
Other global things are affected by the Coriolis effect, one of the most noticeable and well-known being weather patterns.
Winds flow from high-pressure areas, like the poles, to low-pressure areas, like the equator, and back again. However, the Coriolis effect deflects these winds to the right in the northern hemisphere and to the left in the southern hemisphere. The same occurs for ocean currents, the spinning of the Earth and the winds causing the ocean water to circle clockwise in the north and counterclockwise in the south. These factors lead to the spinning of hurricanes and other large and sometimes unpleasant weather patterns. So, the spinning of the Earth affects large fluids and air, leading to global climate. It also affects large planes moving north and south.
However, the Coriolis effect does not have any noticeable results on smaller things like the direction of toilet flushes. Weather, planes, and dragons, not toilets.